Hi everyone, it's Sorkin. Today we have a problem when we are given a heights in two-dimensional array and we have a hiker who needs to travel from this position from top left cell from here from 0 0 to this cell to bottom right cell to here. Let's say that the sizes m to n is to m to n. So he needs to travel here and we need to find a path that requires minimum effort. So the effort is, and we are giving the explanation of the effort is the maximum difference in heights between two consecutive cells. So for example, in this case, the difference is 2, right? Because we are going, the absolute difference is 2, and in this case the absolute difference also 2 between two consecutives, in this case also 2, and in this case also 2 between 3 and 5, so that's why we are returning 5. If we will take this path, for example, if we will take this path, in this case the difference is 1 1, but this one the effort is 3 from 2 to 5, right? From here to here the effort is 3, so we need the minimum effort that we are gonna that is required is gonna be 3, so that's why we are choosing this path. So how we're gonna solve this problem? In this case, if we represent it as a graph, right, this two-dimensional array, then we can use one of the algorithm for finding a shortest path. In this case, we are going to use Dijkstra's algorithm. We are going to use Dijkstra's algorithm, and so how exactly we are going to use that? So in our case, there are different ways how we can implement this algorithm, but in our case, we are going to use a minimum heap, right? So minimum heap. So what we are going to do, we are going to, and we can go from any cell, we can go up, down, left, and right? So for example, in this case, first we can go from 0 0, we can go here and here. So first we are calculating our effort. The effort here is, the effort to go to this position is 2, right? So 2, and the coordinates are 0 and 1, right? So 0 and 1, right? So 0 and 1. So the effort to go to 0 and 1 is 2, right? And how about the effort to go to 1 and 0? To 1 and 0, it is 1, right? Because the absolute difference is 1. So 1 to go from 1 to 0, right? So since it's a minimum heap, so we are going to have that at the top of our heap, so it's our root, right? So we are taking this and we are moving in this direction first. Then in which direction we can go here? We cannot go up because there is no elements, so we are running out of so we are going above of our two-dimensional array, right? So we can go to this direction and this direction. So what's the difference between? It's 0, so it's 0, so we are going here. So now our minimum effort is at this point is 1. So we are moving to the next cell, right? So where we can go from here? We can go again here. We can go here, and the absolute difference, our effort is still 1. Our effort is still 1, right? And once we go here, so what is the minimum effort that is required to go from this position to this position? It equals to 3. We are adding that to our minimum heap, but the next element that we are taking from our heap is 2, right? Is 2, because this effort is 2 is less than 3, so the next one that we are taking from our heap is 2, right? This one, and we are actually moving in this direction now. So we are moving in this direction, and with the same way we are adding in which direction we can go. We can go this direction to right, and we can go to down, right? So we are calculating that, and the 2, so we are adding that again to our heap, and the minimum difference is 2, and the minimum difference also here 2, so we are adding that to our minimum heap, and we are return as we reach our end element, right? As we reach our last cell, so it means that we have the minimum path. So, and we are returning that result. One of the, besides the minimum heap, right, in Java implementation, we are going to maintain priority queue. We also have to maintain array of Boolean to track the cells that we have visited. For example, in this case, we have visited, let's say that we are here, right? We are at 3. Let me put that in another color. Let's say that we are here, and so we need to go up, down, left, and right. So we can go up, right, and down, right? So we have already visited 1, right? So we already know what is the effort, so to go here. So we don't have to visit that again. So that's why for every cell that we have visited, we are going to mark in our two-dimensional array, that array of Boolean, which will be the size of m to n. So the size of our grid. So we are going to mark the cells that we have visited. Okay, first thing that we are going to do, we are going to create a minimum heap. In Java, minimum heap implementation is priority queue. So we are creating a priority queue here, and let's call it minimum heap. It's a new priority queue. And what we are going to pass here. So we need to pass a comparator. In our case, the comparator is, so we are taking an array of integers, and the first element of that integer is the effort. So we are taking that. So we are comparing A and B, the first elements. So A0 minus B0 minus B0. Also, we need to create a visited array of Boolean. That is array of Boolean, which we are going to call visited. And it's a new Boolean. We are, what is the size of it? The size of it is m to n. So our heights length, right? Length. And also we can copy paste that here. So our height's 0, right? 0, so length. Okay, so now we can go and add to our minimum heap. So we are adding our starting point. What's our starting point? We are adding here our new int, right? New int. And we are going to start, the effort is 0 because we are just starting out. And the first coordinates are 0 and 0, right? So our 0 and 0. Now we can go and implement our Dijkstra algorithm. So while our minimum heap is not empty, so it's not empty, what we are going to do here, we are going to pull the first one from our minimum heap, right? So we are pulling the first one from our minimum heap. Let's just call it the current. So we are pulling the top element with which has the minimum effort, right? So we are pulling that, and the minimum heap, let's take it from our heap. And the first element, what's our first element in our current? It's our effort, which is current 0, right? Current 0. We can copy paste it. And the next one is our x and y, right? So it's gonna be the 1 is our x and the 2 is our y. So x and y. So we have our x and y. So one thing what we need to do at this point, we need to, the first thing, let's just check that have we already visited that. If we already visited that, which it means that we need to skip it. So in our visited, so if we have that in our visited, so it means that we already visited that. In that case, we are going to continue. Okay, so we are checking our x and y. If we have it, then we are just skipping it. If we haven't visited yet, then we are visiting it. So we are marking it as a visited. So we are visiting it right now. So it equals to true, right? Now we can go and from this x and y, right, we need to go to 4 directions, to up, down, left, and right. To do that, let's create an array of two-dimensional array of directions that we are going to use. So let's just call it directions. In our directions, so we are gonna have for 4 directions, right? So we are gonna go right, 0 and 1. So we can copy paste this. So we are gonna go to left, which is 1 and 0 and the -1. We are going to up, which is 1 and 0, and we are going to down, so which is -1 and 0, right? So, and we are going to go to every of these directions. So let's do that, and let's do that in our enhanced loops. So let's take each direction. So we are going to take the direction, and our directions. So our directions. And so at this point, we are going to check that. First, we need to check the boundaries. So if, let's say, our direction 0 is our x, and the direction y is our y, right? So the direction 0 is our x, direction 1 is our y. So we are going to check that the x plus direction 0, it should be what? It should be equal or more than 0, right? So it should be more than 0, and it should be less than our height length, right? Length -1. It should be less than. Okay, and we need to do the same for y, right? So for the y, we can actually copy paste this. And we need to do that for y, and here we need to do that for y, and the first one, right? We are taking the first one first, and here we are taking first. Okay, if that condition is met, then which means that we can check the effort, right? So we are checking the effort, and so let's say that we are at position 1, 1, and from there we can go to left, right, down, and up, right? So let's say that we are going to right. So let's say effort going to the right is 2, right? But we need to also consider the effort that we have taken to come to 1 and 1. So for example, let's say that the coming to 1 and 1 is the effort is 3, and the going to the right is the least effort, it's 2. So we are taking the maximum of those efforts. So to do that, we are gonna create here an integer effort, or we are gonna update. We already have effort, so we can use that effort variable. So we are going to take the maximum of our current effort, right? We are going to take the maximum of our current effort, and the effort. So for example, let's say that we are at 1 and 1. So we are taking the effort that took to come to the 1 and 1, and also we are taking the difference. We are taking the current effort going from 1 and 1 to 1 and 2, right? So let's do that. So we are going to take math absolute difference, right? So absolute difference, then from our heights, right? So we are going to take we are going to take x plus direction 0, right? Direction 0, and so direction 0, and this is our x, and we also need to take our y, right? So our y is y plus direction 1, right? So this is our, let's say we are at 1 and 1, this is our 1 and 2 minus the height of the 1 and 1, right? So it's heights x and y, x and y. So we are taking our maximum, we are taking our effort, whatever effort is the maximum, and now we are adding that to our minimum heap. So we are adding that to our minimum heap. So we are adding our effort. So we are creating a new, we are creating our new integer, right? So it's gonna be our updated effort, whatever the effort we have, x plus direction 0, right? And y plus direction 1. Okay, so yeah, one more thing we forgot to do here. If we, before doing all this, we need to check that if we have reached our last cell, right, our right bottom cell, then in that case we are going to return the result. So if our x is equals to heights length minus 1, and our y is equals to heights 0 length, then we are going to return our effort, okay? If we couldn't find it, then in that case what we are going to do, so if we cannot reach the end of our, so we cannot reach the bottom right cell, then we are returning -1 in this case. Okay, I think that's it. Let's run it. Okay, we need to, so here equal, we need to add, so here let's correct it, less than or equal. Okay, so yeah, here, since we are updating the value of the effort all the time, so we can, let's move it directly to the, when we are adding to the minimum heap. Okay, and let's run it one more time. Yeah, it's heights. Okay, let's run it. Okay, yeah, it should be 0 here. Should be 0 here. Okay, -1. Okay, great. It works as expected. Let's calculate the time and space complexity of these solutions. The time complexity is m to n because we are visiting every grid. Also, the cost of the operation adding and removing from adding to our minimum heap is log of m to n. So we need to multiply that to the log of m to n. Log of m to n. How about the space complexity? Space complexity is determined by these two variables, minimum heap and visited, and both of these cases is in the worst case, the space complexity is m to n. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.